Hi, hello. Welcome to i-Tutor NCERT series. Today, we are going to discuss Class 11 Geography NCERT Fundamentals of Physical Geography, Chapter 9 Atmosphere Circulation and the Weather System. Let's start. Air expands when heated and gets compressed when cooled. This results in the variation in the atmospheric pressure. Okay, so the expansion and the compression of air that result the variation in atmospheric pressure. The result is that it causes the movement of air from high pressure to low pressure. Okay, so normally the air move from high pressure to low pressure area. Setting the air in motion, air in horizontal motion is wind. Okay, now the setting the air in the motion, that is the air in the horizontal motion, that is called wind. We know the horizontal motion of air. Okay, so that is this types of motion, that is called wind. Now, atmospheric pressure also determines when the air will rise or sink. The wind redistributes the heat and moisture across the planet, thereby maintaining a constant temperature for the planet as a whole. The vertical arising of moist air cools it down to form the clouds and bring precipitation. So this chapter has been devoted to explain the causes of pressure differences, the forces that control the atmospheric circulation, the turbulent pattern of wind, the formation of air masses, the distributed weather when air masses interact with each other, and the phenomenon of violent tropical storms. Okay, so these are the things we are going to discuss in this chapter. So first one is atmospheric pressure. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere, that is called atmospheric pressure. So what is atmospheric pressure? It is the weight, okay, of a column of air containing in a unit area from the mean sea level to the top of the atmosphere, and this is called atmospheric pressure. The atmospheric pressure is expressed in the units of millibar. At sea level, the average atmospheric pressure is 1013.2 millibar. Due to gravity, the air at the surface is denser and hence has higher pressure. Okay, so the surface air is denser and they have high pressure. Air pressure is measured with the help of mercury barometer or the aneroid barometer. Now, the pressure decreases with the height. Okay, so when height increases, what happens? The pressure decreases. Okay, and height and pressure are inversely proportionate. Now, sorry, at any elevation, it varies from place to place, and its variation is primary cause of air motion, that is wind, which moves from high pressure areas to low pressure areas. Okay. Now, vertical variation of pressure. In the lower atmosphere, the pressure decreases rapidly with the height. Okay, so in lower atmosphere, what happens? Pressure decreases with the rapidly increasing height. The decrease amount to about 1 millibar for each 10 meter increases in elevation. It does not always decrease at the same rate. The vertical pressure gradient force is much larger than the horizontal pressure gradient. Okay, so the vertical pressure gradient force, that is PGF, that is much larger than the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Okay, so it is balanced by a nearly equal and opposite gravitational force. Hence, we do not experience strong upward wind. Okay, so that's why we do not experience strong upward wind. Okay, now that is the vertical variation of pressure. Okay, so there is a pressure gradient force, but there is also a equal and opposite gravitational force. Okay, so we didn't feel the force that much strong. Okay, so that is why we do not experience strong upward winds. Now, horizontal distribution of pressure. Small differences in pressure are highly significant in terms of the wind direction and velocity. Okay, so the small differences in the pressure, they are highly significant in terms of wind direction and its velocity. Horizontal distribution of pressure is studied by drawing isobars at constant levels. Isobars are lines connecting places having equal pressure. Okay, so what is isobar? They are lines which connecting places having equal pressure. In order to eliminate the effect of altitude on pressure, it is measured at any station after being reduced to sea level for the purpose of comparison. The sea level pressure distribution is shown on the weather maps. Corresponding to pressure system, low pressure system is enclosed by one or more isobars with the lowest pressure in the center. Okay, so the low pressure system that is enclosed by one or more isobars with the lowest pressure at the center. Now, high pressure system is also enclosed by one or more isobars with the highest pressure in the center. Okay. Now, world distribution of sea level pressure. Near the equator, the sea level pressure is low and the area is known as equatorial low. Okay, so near the equator, what happened? The sea level pressure that is low and it's known as equatorial low pressure. Along 30 degree north and 30 degree south are found the high pressure areas known as subtropical highs. Okay, so sorry. So the first one, that is equatorial low pressure, that is near the equator region. Then along 30 degree north and 30 degree south, what happened? There is a high pressure area that is known as subtropical high. Further polewards along 60 degree north and 60 degree south, the low pressure belts are termed as the subpolar lows. Okay, so they are known as subpolar low. Near the poles, the pressure is high and it is known as polar high. Okay, just look at this picture. Consider it as Earth. This is equator. Okay. Sorry. This is 30 degree north. This is 30 degree south. Now 60 degree north. This one 60 degree south. This is 90 degree north and here 90 degree south. So this is known as equatorial low pressure. Equatorial low pressure. Okay, so now second one, this area, that is subtropical high pressure. Okay, subtropical high pressure. This is also subtropical high pressure. Now 60 degree north and 60 degree south, they are low pressure belt. So they are known as subpolar low pressure. Here also subpolar low pressure. And this one 90 degree north, 90 degree south, they are polar high pressure. Polar high pressure. Okay, so that is the distribution of sea level pressure. Now, in the northern hemisphere, in winter they move to southward and in summer northward. Okay, so in the pressure belts are not permanent in nature. They oscillate with the apparent movement of sun. Okay, so this pressure belt, they are oscillate with the apparent movement of sun. Okay, they oscillate with the apparent movement of sun. In northern hemisphere, in winter they move southward and in summer northward. Okay, so that is the world distribution of sea level pressure. Now, the forces affecting the velocity and direction of wind. Air is set in motion due to differences in the atmospheric pressure. The air in motion is called wind. Okay, so the air in motion, that is called wind. The wind blows from high pressure to low pressure. So that's we already discussed. The wind at the surface experiences friction. In addition, a rotation of the earth also affects the wind movement. The force exerted by the rotation of earth is known as Coriolis force. So what is called Coriolis force? It is the force exerted by the rotation of the earth. That is known as Coriolis force. Thus, the horizontal winds near the earth's surface respond to the combined effect of three forces. First one, the pressure gradient force, that is PGF, then the frictional force, and finally the Coriolis force. Okay, so the horizontal winds near the earth's surface. Okay, near the earth's surface, that is respond to the combined effect of three forces: the pressure gradient forces, that is pressure gradient force, then frictional force, finally Coriolis force. First one, pressure gradient force. The differences in the atmospheric pressure produces a force. Okay, so the differences in the atmospheric pressure, that produces a force. The rate of change of pressure with respect to distance is the pressure gradient. Okay, so what is called pressure gradient? It is the rate of change of pressure with respect to the distance. That is called pressure gradient. The pressure gradient is strong where the isobars are close to each other, and it is weak where the isobars are apart. Okay, so the pressure gradient force, our pressure gradient, that is strong where the isobars are close to each other, and it is weak whether the isobars are apart. Okay, now frictional force. It affects the speed of the wind. Okay, so the friction force affects the speed of the wind. It is greatest at the surface, and its influence generally extends up to an elevation of 1 to 3 km. Okay, so the frictional force affect the speed of the wind, and it is greatest at the surface, and its influence generally extends up to an elevation of 1 to 3 km. Over the sea surface, the friction is minimal. Okay, so over the sea surface, there is the friction force is minimal. Okay, so we know mainly the continents area, they have a high frictional force. Now, Coriolis force. The third one is Coriolis force. The rotation of the earth about its axis affects the direction of wind. This force is called Coriolis force, after the French physicist who described it in 1844. Okay, so the rotation of the earth about its axis, that affect the direction of wind, and this force is called Coriolis force, after a French physicist who described it in 1844. It deflects the wind to right direction in northern hemisphere and to the left in the southern hemisphere. Okay, so how Coriolis force affect the wind direction? It deflects the wind to the right direction in the northern hemisphere and to the left direction in the southern hemisphere. The deflection is more when the wind velocity is high. Okay, so the deflection is more when the wind velocity is high. The Coriolis force is directly proportional to the angle of latitude. Okay, so the Coriolis force, that is directly proportional to the angle of latitude. It is maximum at the poles and is absent at the equator. So the Coriolis force is maximum at the poles and it is absent at the equator. The Coriolis force acts perpendicular to the pressure gradient force. Okay, so the Coriolis force that acts perpendicular to the PGF. The pressure gradient force is perpendicular to an isobar. The higher the pressure gradient force, the more is the velocity of the wind and the larger is the deflection in the direction of wind. Okay, so the higher in the PGF, the more is the velocity of the wind and it affects larger in the deflection in the direction of wind. As a result of these two forces operating perpendicular to each other, in the low pressure areas, the wind blows around it. At the equator, the Coriolis force is 0. Okay, so we know at the equator what happened, the Coriolis force is 0 and the wind blows perpendicular to the isobars. The low pressure gets filled instead of getting intensified. That is the reason why tropical cyclones are not formed near the equator. Okay, so that's why tropical cyclones are not formed near the equator region. Now, pressure and wind. The velocity and direction of the wind are the net result of wind generating forces. The winds in the upper atmosphere, that is 2 to 3 km above the surface, are free from frictional effect of the surface and are controlled mainly by the pressure gradient force and the Coriolis force. Okay, so the wind in the upper atmosphere, okay, that is above 2 to 3 kilometers, 2 to 3 km surface, they are free from the frictional effect and they are mainly controlled by PGF, pressure gradient force, and the Coriolis force. When isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. Okay, so when isobars are straight And when there is no friction, the pressure gradient force that is balanced by the Coriolis force, and the resultant wind blows parallel to the isobars. This wind is known as the geostrophic wind. Okay, so this wind that is known as geostrophic wind. The wind circulation around a low is called cyclonic circulation. Okay, so if the wind circulates around a low pressure, then it is called cyclonic circulation. Around a high, it is called anti-cyclonic circulation. The direction of winds around such systems change according to their location in different hemispheres. Okay, so the direction of wind around such a system, they change according to their location in different hemispheres. The wind circulation at the Earth's surface around low and high on many occasions is closely related to the wind circulation at a higher level. Generally, over low pressure area, the air will converge and rise. Okay, so generally over low pressure area, what happens? The air will converge and rise. Over high pressure area, the air will subside from above and diverge at the surface. Apart from convergence, some eddies, convention current, orographic uplift along the fronts causes the rising of air, which is essential for the formation of clouds and precipitation. Okay, so that's about pressure and wind. Look at this. Here is convergence, that is coming together. Okay, and this is divergent, that is moving away. Here also convergence, coming together. This is divergence, moving away. Okay. Now, general circulation of the atmosphere. The pattern of planetary winds largely depends on latitudinal variation of atmospheric heating, emergence of pressure belts, the migration of belts following apparent path of sun, in the distribution of continents and oceans, the rotation of Earth. Okay, so these are the patterns of planetary winds. Okay, dependent. Okay, so these are some of the things that depend by the planetary winds. That is the pattern of planetary winds. First one, the latitudinal variation of atmospheric heating, emergence of pressure belts, the migration of belts following apparent path of the sun, and distribution of continents and ocean, finally the rotation of Earth. The pattern of the movement of the planetary wind, that is called general circulation of the atmosphere. Okay, so the pattern of movement of the planetary wind, that is called general circulation of the atmosphere. The general circulation of the atmosphere also sets in motion the ocean water circulates, which influences the Earth's climate. Okay, now the air at the intertropical convergence zone, that is ITCZ, rises because of convection caused by high insolation and a low pressure is created. The winds from the tropics converge at the low pressure zone. Okay, so the winds from the tropics converge at the low pressure zone. The converged air rises along with the convection cell. It reaches the top of the troposphere up to an altitude of 14 km and moves towards the poles. This causes accumulation of air at about 30 degrees north and 30 degrees south. Now, part of the accumulated air sinks to the ground and forms a subtropical high. Another reason for sinking is the cooling of air when it reaches 30 degrees north and south latitudes. Down below, near the land surface, the air flows towards the equator as the easterlies. The easterlies from either side of the equator converge in the intertropical convergence zone. Okay, so the easterlies from the either side of the equator that converge in the ITCZ. Such circulations from the surface upward and vice versa are called cells. Okay, so the circulations from the surface upward and vice versa, that is called cells. Such a cell is the tropics is called Halley cell. Okay, so such a cell in the tropics, that is called Halley cell. In the middle latitudes, the circulation is that of sinking cold air that comes with the poles and the rising warm air that blows from the subtropical high. Okay, so in the middle latitudes, what's happened? The circulation is that of sinking cold air that comes from the poles and rising warm air that blows from the subtropical high. At the surface, these winds are called westerlies, and the cell is known as feral cell. Okay. Now, a polar latitude of the cold dense air subsides near the poles and blows towards the middle latitudes as the polar easterlies, and this cell is called a polar cell. These three cells set the pattern for the general circulation of atmosphere. The transfer of heat energy from the lower latitudes to higher latitudes maintains the general circulation. Look at this picture. You can see the Hartley cell, feral cell, and polar cell. Okay. The general circulation of the atmosphere also affects the ocean. The large-scale winds of the atmosphere initiate large and slow-moving currents of the ocean. Oceans in turn provide inputs of energy and water vapor into the air. These interactions take place rather slowly over a large part of the oceans. Now, seasonal wind. The pattern of wind circulation is modified in different seasons due to the shifting of regions of maximum heating, pressure, and wind belts. Okay, so maximum heating, pressure, and wind belts. The most pronounced effect of such a shift is noticed in the monsoon, especially over Southeast Asia. The other local deviations from the general circulation system are as follows. First one, local winds. Differences in the heating and cooling of the earth's surfaces and the cycles those develop daily or annually can create several common or local or regional winds. Now, land and sea breeze. As explained earlier, the land and the sea absorb and transfer heat differentially. During the day, the land heats up faster. Okay, so during the day, what happened? Land heats up faster and becomes warmer than the sea. Therefore, over the land, the air rising, giving rise to a low pressure area. Whereas the sea is relatively cool and the pressure over the sea is relatively high. Okay, so the pressure over the sea is high and the land pressure is low. Thus, pressure gradient from the sea to land is created and the wind blows from the sea to the land as a sea breeze. Okay, sea to land, that is called a sea breeze. Sea to land, sea breeze. Okay, the name given by where the winds start from. Okay, in the night the reversal of condition take place. Okay, so that is what happened in night. The land cooled suddenly. Okay, the land cools very easily, and what happened? There is a high pressure system created on the land, and at that time the sea is much more heat than land. So there is a low pressure belt. So from the land to sea, okay, the wind move from land to sea, that is called land breeze. The land loses heat faster and is cooler than the sea. So the pressure gradient is from the land to the sea, and hence that is called land breeze. Okay. Now, sorry. Mountain and valley winds. In mountainous region, during the day, the slopes get heated up and the air moves upslope and fills the resulting gap. The air from the valley blows up the valley. This wind is known as valley breeze. Okay, so that is from valley to mountain. That is called valley breeze. During the night, the slopes get cooled and the denser air descends into the valley as the mountain wind. Okay, so in the morning time, what happened? Morning, valley to mountain. That is called valley breeze. Now, night, what happened? Mount to valley. That is called a mountain wind. The cool air of the high pressure and ice fields draining into the valley is called katabatic wind. Okay, so the cool air of the high plateaus and ice fields draining into the valley, that is called katabatic wind. Another type of warm wind occurs on the leeward side of the mountain ranges. The moisture in these winds while crossing the mountain ranges condense and precipitate. When it descends down and leeward side of the slope, the dry air gets warmed up by adiabatic process, and this air mass may melt the snow in the short time. Okay, so that is about the mountain and valley breeze. Now, air masses. When the air remains over a homogeneous area for a sufficiently longer time, it acquires the characteristics of that area. The homogeneous region can be vast ocean surface or vast plain. The air with distinctive characteristics in terms of temperature and humidity is called an air mass. Okay, so the air with distinctive characteristics, that is in terms of temperature and humidity, and that is called an air mass. It is defined as a large body of air having little horizontal variations in temperature and moisture. The homogeneous surfaces over which air masses form are called the source regions. Okay, so the homogeneous surfaces over which air masses forms, and these are called source regions. Now, the air masses are classified according to the source regions. There are 5 major source regions. These are warm tropical and subtropical oceans, the subtropical hot deserts, relatively cold high latitude oceans, the very cold snow covered continents in the high latitudes, and finally the permanently ice covered continents of Arctic and Antarctica. Accordingly, following types of air masses are recognized. 1. Maritime tropical, that is MT. Now, continental tropical, maritime polar, continental polar, and continental Arctic. Okay, so these are some of the air masses. Tropical air masses are warm and polar air masses are cold. Okay, so the tropical air masses, they are warm, and the polar air masses, they are cold. Now, fronts. When two different air masses meet, the boundary zone between them is called a front. Okay, so when two different air masses meet, then the boundary zone between them, that is called a front. The process of formation of the front is known as frontogenesis. Okay, so the process of formation of front, that is called frontogenesis. There are four types of front: cold, warm, stationary, and occluded. Okay, so there are four types of cold. Four types of fronts. First one, cold, warm, stationary, and occluded. When the fronts remain stationary, it is called stationary front. When the cold air mass moves towards the warm air mass, its contract zone is called cold front. Okay, so when a cold air mass towards the warm air mass, then its contact zone, that is called cold front. Whereas if the warm air mass moves towards the cold air mass, the contact zone is called warm front. If an air mass is fully lifted above the land surface, it is called occluded front. Okay, so if an air mass that is fully lifted above the land surface, then it is called occluded front. The fronts occur in middle latitudes and are characterized by steep gradients in temperature and pressure. They bring abrupt changes in the nature and causes the air to rise to form clouds and cause precipitation. So that's about the fronts. Now, extratropical cyclones. Okay, so here also the fronts occur in middle latitudes and characterized by steep gradient in temperature and pressure, and they bring abrupt changes in temperature and they causes the air to rise to form clouds and cause precipitation. Next one is extratropical cyclones. So what are extratropical cyclones? The system developing in the mid and high latitude beyond the tropics are called middle latitude or extratropical cyclones. Okay, so the system developing in the mid and high latitude beyond the tropics. They are called middle latitude or the extratropical cyclones. The passage of front causes abrupt changes in the weather condition over the area in the middle and high latitudes. Extratropical cyclones form along the polar front. Okay, so the extratropical cyclones form along the polar front. Initially, the front is stationary. Okay, so initially they are stationary. In the northern hemisphere, warm air blows from the south and cold air from the north of the front. When the pressure drops along the front, the warm air moves northward and the cold air moves towards south, setting in motion of an anti-clockwise cyclonic circulation. Okay, so what happened when the pressure drops? Along the front, the warm air moves northward and the cold air moves towards the south, setting in motion of anti-clockwise cyclonic circulation. The cyclonic circulation leads to a well-developed extratropical cyclone. Okay, so the cyclonic circulation leads to a well-developed extratropical cyclone with a warm front and a cold front. Okay, so it forms a well-developed extratropical cyclone with a warm front and a cold front. The plan and a cross section of a well-developed cyclone is given in a picture. The picture is not here. You can check the textbooks. These are pockets of warm air or warm sector wedged between the forward and the rear cold air or the cold sector. The warm air glides over the cold air and a sequence of clouds appear over the sky ahead of one warm front and causes precipitation. The cold front approaches the warm air from behind and pushes the warm air up. As a result, cumulus clouds developed along the cold front. Okay, so as a result, what happened? Cumulus clouds developed along the cold front. The cold front moves faster than the warm front, ultimately overtaking the warm front. The warm air is completely lifted up and the front is occluded and the cyclone dissipates. Now, the process of wind circulation both at the surface and aloft are closely interlinked. The extratropical cyclones differs from the tropical cyclone in a number of ways. The extratropical cyclones have a clear frontal system which is not present in the tropical cyclones. They cover a large area and can originate over the sea and land, whereas the tropical cyclones originate only over the seas and on reaching the land they dissipate. The extratropical cyclones affect a much larger area as compared to tropical cyclones. The wind velocity in a tropical cyclone is much higher and is more destructive. Okay, so the wind velocity is also high in the tropical cyclone. Okay, so the wind velocity in a tropical cyclone that is much higher than it is more destructive. Okay. Now, the extratropical cyclones move from west to east, while tropical cyclones move from east to west. Okay, so the extratropical cyclones are move from west to east, and the tropical cyclones move from east to west. Now, tropical cyclones. Tropical cyclones are violent storms that originate over oceans in tropical areas and move over to the coastal areas, bringing about large-scale destruction caused by violent winds, very heavy rainfall, and storm surges. This is one of the most devastating natural calamities. They are known as cyclones in the Indian Ocean, hurricanes in the Atlantic, typhoons in the Western Pacific and South China Sea, and willy willies in the Western Australia. Okay, so the tropical cyclones are known as different names in different places. Tropical cyclones originate and intensify over warm tropical oceans. The conditions favorable for the formation and intensification of tropical storms are: first one, large sea surface with the temperature higher than 27 degrees Celsius. Okay, so the temperature should be higher than 27 degrees Celsius. Presence of the Coriolis force. Okay, second one is presence of the Coriolis force. Third one, small variations in the vertical wind speed. Now, a pre-existing weak low pressure area or low level cyclonic circulation. And final one, upper divergence above the sea level. Okay, so these are some of the conditions for the intensification of tropical storms. Now, The energy that is intensifies the storm comes from the condensation processes in the towering cumulonimbus clouds surrounding the center of the storm. With continuous supply of moisture from the sea, the storm is further strengthened. On reaching the land, the moisture supply is cut off and the storm dissipates. The place where a tropical cyclone crosses the coast, that is called the landfall of the cyclone. Okay, so the place where a tropical cyclone crosses the coast. Okay, for example, this is land and this is ocean. Okay. Now, when a tropical cyclone reaches this point, that is the coastal area, okay, from ocean to land, and this area, this is called the landfall of cyclone. Okay, this area is called landfall. Okay, because this area they cut off the storm. Okay, they cut off the moisture supply. This area cut off the moisture supply, and thereby the storm dissipate. Okay, and this place that is called landfall of the cyclone. The cyclones which crosses 20° north latitude generally recur and they are more destructive. Okay, so the cyclones which cross 20° north latitude, they generally recur and they are more destructive. A mature tropical cyclone is characterized by the strong spirally circulated wind around the center, and this is called I. Okay, so the mature tropical cyclone that is characterized by a strong spirally circulating wind around the center. Okay, so there is a strong spirally circulating wind around the center, and that is called I. The diameter of the circulating system can be vary between 150 and 250 kilometers. Okay, so the diameter can be vary from 150 to 250 kilometer. Now, the eye is a region of calm with the subsiding air. Around the eye is the eye wall, where there is strong spiraling ascent of air to great height reaching the tropopause. The wind reaches maximum velocity in its region. Okay, so in this region, that is the eye wall region, what happened? The wind velocity is maximum, reaching as high as 250 km per hour. Torrential rain occurs here. From the eye wall, rain bands may radiate and trains of cumulus and cumulonimbus clouds may drift into the outer region. The diameter of the storm over the Bay of Bengal, Arabian Sea and Indian Ocean is between 600 to 1200 km. The system moves slowly about 300 to 500 km per day. The cyclonic crust storm surges and they inundated the coastal lowlands. The storm peters out on the land. Now, thunderstorms and tornadoes. Other several local storms and thunderstorms are tornadoes. Okay, they are of short duration, occurring over a small area but are violent. Thunderstorms are caused by intensive convection of moisture hot days. A thunderstorm is a well-grown cumulonimbus cloud producing thunder and lightning. When the clouds extend to heights where sub-zero temperature prevails, hails are formed and they come down as hailstorms. Okay, so when there is a low temperature, then what happens? That is the sub-zero temperature. Then hails are formed. If there is insufficient moisture, a thunderstorm can generate dust storms. A thunderstorm is characterized by intense uplift of the rising warm air, which causes the clouds to grow bigger and rise to greater height. This causes precipitation. Later, downdraft brings down to the earth the cool air and the rain. From severe thunderstorms, sometimes spiraling wind descends like the trunk of an elephant with great force, with very low pressure at the center, causing massive destruction on its way. Okay, so from severe thunderstorms, sometimes spiraling winds descending like a trunk of an elephant and with a great force, and it have a very low pressure at the center, and this causing massive destruction on its way. Such phenomenon is called a tornado. Okay, so this phenomenon, this much destruction causes thunderstorms or the low pressure area, low pressure belt, that is called tornado. Tornadoes generally occur in the middle latitudes. The tornadoes over the sea is called water spouts. Okay, so the tornadoes over the sea, that is called water spout. Water spout. These violent storms are the manifestation of the atmosphere's adjustment to varying energy distribution. The potential and the heat energy are converted into kinetic energy in these storms, and the restless atmosphere again return to its stable state. Okay, so that's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.